Welcome to part 9 of our series on quadratics, and today we're going to look at solving quadratics by completing the square. Okay, now we have here three quadratic expressions. Okay, I've plotted the graphs of those over here, so you can see roughly where the solutions would be to the equations where these expressions equal 0. So I'll just turn them all into equations first. So these are the three equations that we're going to solve. Okay, now the first one could be factorized, and we'll do that in a moment, but I'm going to start by completing the square with that one, as I will do with the others. So question 1 I'll do here. The first thing I'm going to do is look at the structure of the quadratic and make sure it's in the order ax squared plus bx plus c. And then I'm going to look at the x squared coefficient and note that it's 1. So it's quite a simple process. I just have to halve the x coefficient and do the perfect square. So I'm doing the perfect square of x minus 1. Okay, and I'm finding that that gives me x squared minus 2x, okay, plus 1. Now, of course, I was expecting the x squared and the minus 2x. That's why I did it. But it's the 1 I've got now that I need to adjust to give minus 8. So I need to take away 9 from this. So I need to take away 9 from this. So my original equation can be written as x minus 1 all squared, okay, minus 9 equals 0. Okay, and then you set about solving it in the way you would any equation. Just do the same thing to both sides. So I'm going to do x minus 1 squared equals 9, just by adding 9 to both sides. Okay, then I'm going to square root both sides. So x minus 1 is going to be equal to the square root of 9. But at this point we introduce the plus and minus, recognizing that there are positive and negative values that solve that. Okay, and then I'm going to add 1 to both sides to give me x equals 1 plus or minus root 9. Or I'm just going to write plus or minus 3. Okay, now the fact that the number under the square root is a square number means that this equation would factorize, and indeed it does. So the solutions are that x is 1 plus 3, okay, or x is 1 minus 3, which is minus 2. And I think you can see on the graph, if you look at those two places there, there's the negative 4, the negative 2, and there's the 4. Okay, and just to show the factorization, which in this case, of course, would have been quicker, we would have that factorizing to be x minus 4 times x plus 2. And when we solve that, we would have got, of course, the same solutions as we did here. Okay, so that is how you would solve that by completing the square, and those are the solutions. Question 2 is the blue graph here, and you can see that the solutions are somewhere in between values. We don't know what they are. And they won't be exact because this doesn't factorize. Well, they'll be exact, but they will be in surd form because this doesn't factorize. Okay, so question 2 will be here, and I'm going to do the same, much the same as I did in question 1. I'm going to do the perfect square of x plus 1 this time, because I have x squared plus 2x, and that gives me x squared plus 2x, okay, plus 1. But I don't want plus 1, I want minus 5. So I need to subtract 6 from this. So my original equation could be written as x plus 1 all squared minus 6 equals 0. Okay, and now I just need to go through the same steps as I did before. X plus 1, therefore, x plus 1 squared equals 6. Okay, and then I will have x plus 1 being the square root of 6 plus or minus, and then I just need to subtract 1 from both sides, and as I said before, we tend to put that in front of the surd. Okay, minus 1 plus or minus root 6. Okay, if you put it afterwards, if you put the 1 at the other end, you need to make sure that the surd root sign, the square root sign, ends abruptly and doesn't look as if the minus 1 is included in the square root as well. So it's better to put it at the front. Okay, right, so that gives basically two solutions, and that is that x equals negative 1 plus root 6, okay, and negative 1 minus root 6. Okay, x equals negative 1 minus root 6. Now those two values are shown clearly on the graph. They come to about, that one does come to about this one comes to about minus 3.5, and that comes to about 1.5. Okay, so that's the second one done, and if you wanted calculator values, you'd obviously just put those two onto the calculator. Right, and number 3. Now this one is a little bit more tricky because you have the coefficient of 2 in front of x squared, but this is how it works. I'll just partition that off. We've got some space to work with, and this is what happens here. Okay, so we start with writing the whole equation out by taking out the factor of 2 from the front. So 2 lots of x squared plus 3x, and then it's going to be minus 7 halves, 7 over 2, equals 0. Okay, now because you're solving this equation, you can just remove that 2, because you're dividing both sides by 2, and if you divide 0 by 2 you get 0. There's nothing wrong with that. The thing to be aware of though is if you take away the 2, the information that you get about the minimum point on the curve, you lose some of that, because the factor of 2 would affect this number at the end here. So, but if you're just solving the equation, it's fine, you just lose it. So I can now say, I'll just rewrite it without the 2, x squared plus 3x minus 7 over 2 equals 0. Okay, and now I do exactly the same rules as I did previously. I have to take out, halve the x coefficient, and then do the perfect square. So I'm interested in the perfect square of x plus 3 over 2, all squared. Okay, and that will give me the x squared and the 3x, because 3 over 2x plus 3 over 2x is 3x. But it will give me a residue of 9/4. Okay, the square of the last term. But I don't want 9/4, I want negative 7 halves. Now negative 7 halves is negative 14/4. So basically what do I need to do? I'll just write it up here. I want to go from 9/4, okay, and I want to go down to negative 14 quarters. Okay, so hopefully you can see that that means I've got to subtract 23 quarters. So my equation becomes this: x plus 3 over 2 all squared, okay, minus 23 quarters, okay, equals 0. So I just do the usual things to solve the equation. I'll just move over here now. So if I just put another one of those lines down just to make another column to work in. So if I come across here now, then I've got x plus 3 over 2, x plus 3 over 2 squared would give me 23 quarters, and then I need to square root, so x plus 3 over 2 would equal plus or minus the square root of 23 quarters. Now I'm going to write that as root 23 over 2, because if you square rooted the whole fraction, you'd be square rooting the 4 underneath to give you 2. It's a bit tidier like that. And now I just need to subtract the 3 over 2. So x equals negative 3 over 2, okay, plus or minus root 23 over 2. Okay, and quite often you would write that as a single fraction with a common denominator. So I would tend to write that, unless the question asked you to leave it like that, I would tend to write minus 3 plus or minus root 23, okay, all of that over 2, okay, and that's a slightly neater way of doing it. Or you could separate the two solutions out as we did here, or you could put them in on the calculator in turn and give them to 3 significant figures if that's what the question requires. But these are the exact answers, and if you put those on the calculator, check against these two solutions here, you'll find that they are pretty well what you'd expect from that graph. Okay, now just one thing I'll say to conclude this video. You might notice that when we were dealing with the residue here, as I call it, they were negative numbers, so we added to both sides. Okay, so the thing we had on the right hand side was a positive number here, you see, 23 over 4. Here we had a positive number 6. Here we had a positive number 9. Okay, so when we took the square root, there was no difficulties. If you find that the residue is positive, in other words, this was a plus here, or this had been a plus here, then it means that the quadratic wouldn't have any roots or solutions, certainly not any real roots or solutions. Or, in other words, the graph would be not crossing the x-axis. Okay? Right, that's it.